Welcome to the Survey of Physical Sciences. I am the professor for this course. The first item to discuss is the meaning of a survey course. Survey courses are intended to make students aware of the various types of subjects within a discipline. After all, if you did not know that thermodynamics is the scientific name for the study of heat, how would you know? And hey, once you know something, it just might interest you. Survey courses are name droppers. What do you call a person who studies frogs and toads for a living? Right, a herpetologist. And the study itself is called herpetology. But who doesn't know that, right? Moreover, it is a sub-study of the bigger science of zoology. And this is a sub-science of the even bigger science of biology. How do I know all that? I took survey courses in college. Without computerized spell check, I probably could not spell herpetologist on an exam tomorrow. But I know it exists as a field of study, and that is the main function of survey courses. Our 600-page survey text makes no mention of frogs, because frogs do not belong to the physical sciences. Quite simply, as I like to say, these are the sciences that are not bloody, green, or slimy. That is biology. We look at astronomy, chemistry, geology, meteorology, nuclear physics, etc., i.e. the non-biological sciences. Okay, let's begin with trying to understand what makes a statement scientific or non-scientific. The textbook spends a great deal of time discussing hypothesis and method. But quite simply, it comes down to this. In order for a theory to be considered scientific, it must also be possible to potentially disprove it. For example, I say all unicorns are solid. Can you prove me wrong? No, because the hypothesis is not sound, or rather it is non-scientific. Understand? Take this one. 200 million years ago, Martians came to Earth and rearranged the continents. Is that a scientific statement? Yes or no? Obviously, the answer is no, because you cannot prove it wrong. Therefore, it is just an opinion or science fiction. It is not an idea you can disprove. Thus, it is not a scientific statement. I would call this a survey of the scientific method. The rest of Chapter 1 looks at our early knowledge of earth and sky. By the time of the Greek philosopher Aristotle, about 350 BC, thinkers had come to believe the idea that the earth is flat, stationary, and the whole universe spins around us. This is called geocentrism. By the time of the Greek philosopher Ptolemy, circa 150 AD, this geocentric theory became the scientific point of view for the next 1,500 years. The correct understanding that Earth moves and revolves around the sun did not arrive until Nicholas Copernicus' work in 1543. This theory is called heliocentrism. In the centuries that followed, Kepler worked out the three basic laws of planetary motion, and Newton formulated his law of gravity. Modern physical science begins with Isaac Newton's work in the 17th century. And that ends the Module 1 video presentation. Thank you.